Live streaming of SDR news coverage at HP Discover has been made possible by Intel Corporation. Check out Intel OpenPort IT, where you can connect with your peers at Intel on industry topics, best practices, strategies, and more. And by Microsoft, where HP and Microsoft are working together, combining their respective strengths to deliver innovative technologies to help advance your business.
Traveling to Barcelona, we had some critical studio gear damaged by airline mishandling. That resulted in degraded audio quality during some of our interviews. We've edited the backup recordings of the interviews for maximum clarity possible. We'll offer each guest a chance for re-recording. Please watch for announcements on the Twitter stream, AXMC, and SDR News for updates.
Welcome back to our coverage here at HP Discover in Barcelona. I'm Andy McCaskey from SDR News, and we continue to cover all sorts of topics, but we've got a real treat coming up for you right now. One of our guests in multiple environments here, Simak Nazari, is from the storage group at HP. What is your role exactly?
I'm the Chief Software Architect for the HP 3-Power InfoMOS, which is the primary software that runs on the 3-Power line of products.
Yes, and you've also received some honors as an HP
I'm also an HP fellow.
Yes. HP fellow as well. Well, what is it about the 3-Power architecture that enables you to have a very small entry-level product, but keep that same storage architecture all the way up to the very largest enterprise system? This is almost unheard of in the industry. What makes it possible?
I think it has to do a lot with the initial set of decisions we made. Rather than think about a storage architecture, we talked about a system or server architecture. So if you think about operating systems, such as Linux, where it runs from on your phone all the way to 64 CPU machines, it's the same server operating system, but it's trimmed down or modified to run here and there, but it's architecturally the same thing. And that's precisely what we decided that we want to build. We wanted to build primarily a server architecture that was able to actually scale up and down, right? And some of it was also the fact that we wanted to build systems that would go from 2 nodes all the way to 8 nodes.
What drives the need for a tremendous range as opposed to having multiple sizes?
It's the customer's needs and agility, really. The last thing you really want to do is to learn something, and then when you upgrade, you have to go learn something brand new again, and re-implement the entire thing. And now you have 2 sets of silos, right? The old stuff and the new stuff, right? And then now you have to also make another decision when another purchasing comes up. Do I buy the smaller box, or do I buy the bigger box with the bigger capital outlay to begin with, right? So we just wanted to get away from those sort of compromise decisions that we have to make, right? Buy the right box, and if it's too small, grow it. If you want a second box or a much larger box that has much bigger headroom, buy the same architecture so that all your learning and all the physical configurations that you learned and cabling just applies. And beyond it, if you think about the model where you're trying to set up 2 data centers, a primary and a secondary data center, or a hub and spoke environment where you have a lot of little data centers spread all over the place, and you have one big main data center. In the main data center, you want to have a big system that replicates the data in and out to the smaller data centers. Well, in the smaller data centers, you want smaller boxes. In the big data center, you want a bigger box. But you want compatible architecture so you could actually connect them and have them harmonize and actually send the data back and forth. So having a common architecture that goes from small to large allows you to solve a different set of problems that you couldn't really solve before.
Yeah. So this sounds a wonderful whiteboard sort of solution. Everybody can see this is desirable. What were some of the hidden things that you had to overcome in order to realize this vision?
So a lot of it had to do with really designing it from the ground up, but then as you go and you decide that you have to start to make compromises, right? Well, if a smaller system has only so much memory and a larger system has a lot more memory, then your caching changes, your caching algorithm changes. If you have 2 CPUs versus 64 CPUs, your locking algorithms change. So these are the kind of stuff that we had to learn and do over time.
But your component parts are changing in their capabilities as well as you are changing. You have to react to what's happening.
Exactly. It's sort of, there's 2 parts to it. It's optimizing it on the fly and optimizing it while you're actually writing the code, right? Optimization on the fly is to learn what the system behavior is and adjust. And also optimization when you're trying to put out a specific platform and then you sort of make the right set of choices for that particular platform.
Here at HP Discover, there was increased discussion of the general topic of flash, and you've introduced a new product that's kind of a mid-range box.
That's right.
But has exceptional performance.
That's
So
right.
tell us about that.
So that's a particular piece of technology that we are quite proud of, in the sense that if you look at that system, it does 900,000 IOPS at less than 700 microsecond latency. And it does it really by 4 nodes, and there's a total of 4 CPU sockets involved. If you compare that to the others, and what they have to do to get a million IOPS, they have to throw a lot more sockets at it. That says something about the efficiency, the inherent efficiency of the product itself. And the fact that we got to 900,000 IOPS just with a software release for the same system that could do 550,000 IOPS, now it does 900,000 IOPS, it just tells you the quality of the software and the way to go in and actually fine-tune. And the fact that there is so much headroom in the hardware that the software can just tap and then bring this sort of performance increases over time into the platform is pretty interesting.
Well, as you look across the marketplace, I think there are several competitors that would have multiple architectures in order to achieve the range.
Right.
If someone goes down that path, what are the implications of, as they grow, how do you get from one level to another?
Well, the difficulty is having, if you have an application that really needs flash performance, both in latency and IOPS, right? Then you have to make one purchasing decision, and then one set of usability options that you have to learn. And by the way, it does not interoperate with something else if you want to set up a disaster recovery with existing. So you have to buy 2 of the new stuff and learn it. Versus if you want something that has only nearline drives because it's your archival storage, right? Then you have to make a different purchasing decision, right? And so all those things just add a lot of complexity to an environment that is already complex enough, right? You really need more, right? In complexity.
We don't need more complexity. Where can people go to find more about 3PAR capabilities and some of the things we've been talking about?
hp.com/3PAR.
/3PAR.
Yes.
And of course, Calvin Zito, the HP storage guy,
Exactly.
and his blog as well.
Absolutely. Yeah.
Simak, always a pleasure to speak with you.
Much.
And thanks to you folks for joining us as well on our continuing coverage here at HP Discover from Barcelona.